And okay, next. Yes, we have solved this problem, but I'm going to go over it one more time. If we have a sample, this sample contains 0.8633 gram sample, and it contains chloride ion. Part of it contain chloride ion. I want to know how much chloride ion available in this sample. This is the mass of the whole sample. I want the mass of the chloride ion only. All right. What I'm going to do is, we know that if you put the sample which contain Cl minus and you add to it AgNO3, what will happen? Ag and Cl will precipitate to make AgCl as solid plus NO3 as ion. All right, now the mass of AgCl was 1.5615 gram. From this, if I have AgCl, I have 1.5615 gram AgCl. Can I change this to mole?
Yes, divide by the molar mass.
What's the molar mass of AgCl? Yes.
$143.32.
Anybody got the same answer?
Yes, doctor.
Yes.
3.32.
Gram AgCl. This way, get rid of this gram of HCl with gram HCl. And I know that 1 mole AgCl contain how much? What should I write at the top?
The molar mass of Cl.
Mole, no, mole is mole. Mole of Cl minus. And then this will go with this. And then 1 mole Cl minus is 35.45 gram Cl minus. Give me the mass of from this, give me the mass of Cl minus.
0.39.
0.39, some more.
It is actually 0.386.
386 gram Cl minus. Now divide this by this mass and get the percentage. What's the percentage?
$44.74.
4.73 actually is the correct answer, which is acceptable. I hope this is clear. We discussed this last time, so I just want to review it. Next, we will do what's called acid-base titration. Acid-base titration, very important word and work that we always do in chemistry. When you add acid to base, what are you going to get? Always.
Salt and water.
H2O.
Salt
and water.
and water. And what do you call this type of reaction?
T3.
No, what we call the reaction.
Neutralize.
acid base neutralize.
Neutralization reaction. What's neutralization means? You neutralize the acid and the base. No acid. معادلة. There is no acid and no base in solution. The process that we do when we add acid to base is called titration. So titration is actually the process of adding acid to base is called titration. Titration. We usually use standard solution. What does standard solution means? It means that we know the molarity. Standard solution means we know the molarity. That's the meaning of standard solution, whether it's acid or base. Whatever we know the molarity, then we call this standard solution. To do this, we add acid to base, and in order to reach to the end point, okay, to reach the end point or equivalence point, to reach the equivalence point or to the end point, we put indicator. This is the acid and plus base to give salt and water. When are we going to reach the equivalence point?
When there is no acid and base.
When the amount of acid
Completely neutralized.
yes, completely neutralized. Amount of acid and base is what? Exactly the same. Not amount, but mole. Mole, when we say amount, I mean mole, amount in mole of acid and base, exactly the same. This means in solution, we don't have acid or base. No more acid, no more base. What we have is just salt and water. And this is the neutralization point. We also call it the equivalence point. We can also call it the end point. The equivalence point or the end point. To reach the equivalence point or the end point, we have something that's called indicator. Indicator. Indicator in Arabic, it's called what?
الكواشف.
مؤشر.
الكاشف أو الكواشف, yes. The indicator, what's the property of the indicator?
Change of its color,
It
depending
will
on the
change
method.
reach the equivalence point or the end point. When you reach the end point, the kashif or the indicator will change color. Good. And that's what will happen here. When you add acid to the base here, when the colors start changing, what does that mean?
The reaction is completely, or
And
the acid equal the base.
Which point we reached?
End point
The
or
end
equivalence
point.
The equivalence
Or
point.
the, what's the other name?
End point.
Equivalence point.
Equivalence.
Neutralization point.
Equivalence. Neutralization point. All of this is acceptable. We reach the end point, we reach the equivalence point, we reach the neutralization point, no problem. All right, good. Okay, there are different type of indicators. One of them is called phenolphthalein. This one is called potassium hydrogen phthalate. Potassium hydrogen phthalate. You don't have to know anything about this one. It's just called potassium hydrogen phthalate. Or there are the other things which is called طبعا يمكن مرت عليكم هذه الليتمس بيبر. من يعرف الليتمس بيبر؟
هذه اللي إذا حطيتها في أسد تصير حمراء.
ظنها ورق عباد الشمس بالعربي يسموها ولا لا؟
تباع ايوه.
ايوه تباع.
تنباع موجوده. لو سالت عنها في المكتبات حتجد الليتمس بيبر. الليتمس بيبر ايش اللون حقها في الاسد؟
احمر.
أحمر.
بالضبط. وفي البيس
اخضر.
أزرق.
ازرق. يس. هذه واحده من الانديكيتورز. Is this clear? All right.
Clear.
Good.
Yes, doctor.
Good. Let's solve this problem. We have here the reaction is between an acid, which I'm going to call KHP. KHP is the acid, okay? And base. In a titration experiment, a student find that 25.49 millimeter of NaOH. So we have NaOH. All right? Now, if you have a reaction like this is the acid and this is the base. What will be the product?
Water and salt.
What's the salt?
Na and HP. K.
Okay, be more careful. Na what?
NaCl.
Remove H from KHP.
Exactly. Kp plus what?
Water.
Exactly. That's the reaction always. When you add base to acid, then it will give you salt. Take the hydrogen away and take the OH away to make water out of it, and then write the rest. Okay, let's have the information under each thing. In titration experiment, the student find that 25.49 millimeter, so 25.49 milliliter, okay, of an AOH solution is needed to neutralize 0.7137 gram kpH. Okay, what is the concentration of NaOH, Na of the solution? So we don't know what's the molarity. We're asking about the molarity. What information you have? You have the mass of the acid and you have the molar mass of the acid. This is the actual acid. This is the shape of the acid and this is the total mass. So what's the first step you're going to do?
Find the number of moles.
Moles what?
KHP.
KHB, exactly. What should I write?
0.7137 divided by molar mass.
KHP multiplied by what?
1 over molar mass.
Yeah, 1 mole KHP divided by 204.2 gram KHP. You have an answer?
3.495 495 times 10 to the power minus 3.
Who got the same answer?
Minus 3.
Minus 3. I believe you. I don't know what is it. Mole
It's
KHP.
the same answer.
Good, excellent. Then how many mole NaOH do I need for the neutralization?
The same.
It's a 1-to-1 because this one is 1-to-1. So this amount is 3.495 times 10 to the power minus 3 mole needed. If I know the volume, which I will change it to liter, so it's 25.49 times 10 to the power minus 3 liter NaOH, then can you find the molarity?
Divide the mole over the volume.
Exactly. Give me an answer quickly. Divide the moles by the number of milliliters. That's all, or the liters. Give me an answer.
0.137.
137 molar. Who got the same answer?
Yes, it's the same.
Excellent. So we have more than 1.1371, and it is correct. Good.
Doctor,
Yes.
will the molar mass of this acid be given in the question?
Yeah, of course. Well, I can. No, I don't have to, but it's too much. Of course, you can calculate it. Can't you calculate it?
I mean, if he asked us about KHP, I don't know the formula of the.
No, if I give you KHP only, I must give you the molar mass. But if you want to calculate it for this one, you can do it. Oh, actually, it's done here.
Okay, thank you.
Good.
Doctor,
Yes.
can you repeat the last step? I didn't understand it.
Well, what do you have? You have number of moles. Do you know how to find the number of moles?
We divide.
No, actually, we found the moles for KHP, which is the mass of KHP, which is 0.31737 gram KHP, and divide by the molar mass, 204.2, and this gives us the number of moles. The number of moles of KHP, because this one is 1-to-1, this must be the same number of moles here. The number of moles of NaOH is the same number, which is 3.495 times 10 to the power minus 3 mole. I know that I use in this reaction 25.49 milliliter, so I change this to liter, and I divide the mole, divide by liter, and this gives me the molarity. As simple as that.
Always we use liter, right, doctor?
Of course, if it's mole, it must be liter, of course. Molarity is moles per liter. Good. What volume of an AOH solution is needed to neutralize? So I have an AOH solution. I want to neutralize it with H2SO4, and I want to know what's the volume. Volume of NaOH is unknown, but I know that the molarity here is 0.203 molar in NaOH, and I know the volume for H2SO4 is 25.0 times 10 to the power minus 3 liter. Okay, 25 I multiply by 10 to the power minus 3. And I know the molarity is 0.188 molar solution. Can you calculate the number of moles?
M1V1 equals M2V2.
We
How?
find the mass first.
I want you to tell me how many moles H2SO4.
We multiply the volume
4.7.
times the
Exactly.
molarity.
Multiply what?
The volume with the molarity.
4.7 times 10 to the power minus 3.
Actually, this is molarity So what should you do to calculate number of moles?
Multiply the volume with molar.
Simply multiply 25 times 0.188 mole. And what's the answer?
.7 times 10 to the power minus 3.
Mole, exactly. Mole is 2, so 4. How many moles in AOH do I need to react with it?
Multiply by 2.
9.4.
9.40 times 10 to the power minus 3 mole. If the molarity is 0.203, what's the volume?
The mole over the molarity.
Exactly, mole over molarity.
It will be 0.0463.
0.0463. 463, exactly. Or this is liter, of course. Make it a milliliter. 0.0463 liter. What is it in liter?
Multiply by 10 to the power 3.
Which is what? 46.3 milliliter. Is this clear? How easy?
Doctor, where did you get the moles from? The number of moles.
But they get what?
Where did we get the number of moles so we could find the?
For what? For H2SO4 or for any?
I'm sorry. I mean, how did we get the millis, the volume for 2 in AOH?
Yeah.
It's the same. Is it 25?
No, I have the number of moles because what I did, let me repeat what I did exactly. We treated 25 times 10 to the power minus 3 liter of H2SO4 which has 0.188 molar. I multiply this by this. This means 25.0 times 10 to the power minus 3 liter times 0.188 moles H2SO4 per 1 liter solution. That's what's molarity, 0.188 times a liter solution. The liter will go with liter, and you have the answer. It will be 4.70 times 10 to the power minus 3 mole H2SO4. Now,
yeah, it's good, Doctor. I get it now. Thank you.
Okay, now 1 mole of this one needs 2 moles of this one. So how many moles of an AOH we have? We have 9.40 times 10 to the power minus 3 mole in AOH. You get the moles in AOH. Why? You multiply this by actually 2 to get to this one. All right, because it is 1 to 2. Then, if you know the number of moles and you know the molarity, what should you do? You should take the 9.40 times 10 to the power minus 3 mole in AOH. Should I divide or multiply by molarity? Actually, I should multiply by 1 over molarity. Why? Because it will be 0.203 moles per liter. This means I multiply 1 over or divide by molarity. The moles will go with moles, and you have the answer in liter. And somebody told me it is 0.0463 liter, or I want to change it to milliliter. I just say 46.3 milliliter. I hope this is clear.
Doctor,
Yes.
I can use in this question M1 multiplied by V1 equals M2 V2.
M1 V1. I know. Yes. Well, I don't know. No, I prefer to use molarity. Yes, you can use that one, but you have to be very, very careful. All right. I prefer to use molarity. Good. We have here another question. 0.1216 gram sample of monoprotic acid. What's the meaning of monoprotic acid?
It gives up for one hydrogen when it dissolves.
One hydrogen only. So the acid is HX. Okay, is dissolved in 25 milliliter of water. So what's the volume of this acid?
25 milliliter.
25 milliliter. Good. And resulting solution with it was titrated with what?
NaOH.
AOH.
What was the molarity of NaOH?
0.1104.
What's the volume needed to make the neutralization?
12.5.
20.5 milliliter.
5 milliliter. Okay, can you calculate moles of NaOH?
Multiply the concentration with the volume in liter.
4 moles per liter multiplied by what? 12.5 times 10 to the power minus 3 liter. The liter will go with the liter, and you have the answer is the moles. What's the answer?
1.38 times 10 to the power of minus 3.
Yes.
1.38
Times 10 to the power.
minus 3 mole. Good. How many moles of HX we need?
The same, because 1 to 1.
It's 1 to 1. That's why moles HX equal to what? 1.38 times 10 to the power minus 3 mole. All right. What's the molar mass of HX of the acid? What are you going to do? What's the molar mass?
Mass in gram divided by the number of moles.
Exactly. What's the unit of molar mass?
Gram per mole.
Gram
per over.
mole. You have this already in mole, and you have the mass in gram. How can you get gram over mole? Divide 0.1216 gram divided by 1.38 times 10 to the power minus 3 mole. Okay, and what's the answer?
88.115.
8.116.
116.
116. Okay, gram per mole. Who got the same answer?
Me.
Yes, doctor.
Do you know how to solve these problems? Yes.
What is the benefit of 25 milliliter?
Nothing. In this case, nothing. At the beginning, I thought it would be important because maybe he wanted molarity. If it's molarity, then we have to do something. But no. So this one is useless information.
Doctor,
Yes.
how we know that ratio is 1 to 1? Because we didn't get the full equation.
How about what does it say here?
Okay. Okay.
Okay, so there is one hydrogen only.
Yes.
And of course, HX with NaOH will give me in A, X plus H2O. Clear?
Clear, doctor. Clear.
And it's 1 to 1, exactly. Good. Right. Next, we can also use the titration, same thing like what we did with the acid and base for redox reaction. What's the meaning of redox?
Reduction oxidization.
Reduction, oxidization, reaction. Okay, good. Same thing, we'll do like titration. This is titration. We use even the word titration to do this. And this is example of acid-base reaction. Is this acid-base reaction? I mean, not acid-base. Is this redox reaction, the reaction that you're looking at? Is it redox reaction? The answer is yes. Tell me why. What's the oxidation of manganese in here?
+7.
No, in here.
+2.
Plus 2. What is it here?
+7.
+7. So what happened to the manganese?
Reduced.
We reduce it to +2 because we added 5 electrons. How many electrons we need to add to it?
5.
5 electrons. Good. What has been oxidized?
MnO4.
No. Look at metal.
The carbon.
Yes, the carbon. Why? What's the oxidation of oxygen in here?
-2.
What is it in here?
Also -2.
And here?
-2.
So what happened to oxygen?
Nothing.
Nothing. How about hydrogen? What's the oxidation of hydrogen in here?
+1.
In here?
+1.
+1. What happened to hydrogen?
Nothing.
Nothing. Okay, what's the oxidation number of carbon in here?
+6.
3.
Yes, +3, not 6. +3, exactly. What is the oxidation number of carbon in here?
+2.
No.
4.
+4.
+4. +4. Because actually in here it's clear -2 for oxygen times 2 is -4, so this must be +4. And this one, it was -2 times 4 is -8, and this one C2, but there is -2 at the top. That's why this is +6 for 2 carbons. Each one is +3. Is this clear? Good.
Doctor, can you explain the carbon, please? Oh, we can.
Again, yeah, okay, no problem. Okay, the carbon here, I mean the C2O4 2 minus. Well, let's okay. What's the oxidation of oxygen? Always. Yes, oxygen.
-2.
-2. And we have 4 of them. What's the total?
-8.
-8. What must be the oxidation of carbon in this case? All the carbon. +6. Why? Because +6 -8 is equal to what? -2, which is this one. But this is +6 for 2 carbons. What is it for each carbon?
+3.
+3 for each carbon. Is this clear?
Yes.
I hope so. Good. Let's have this example. Is this oxidation reduction reaction? Look at the reaction only at this time. Yes or no? Huh?
No.
It is oxidation. The answer is yes. Then tell me why. Look at iodine only. I don't want you to look at anything else. What happened to the iodine? What's the oxidation of iodine in this case?
From 0 to -1.
So
Reduced.
it has been reduced. Don't worry about the rest. Since it has been reduced, there's something has been oxidized, but I'm not going to say which one has been oxidized. But this is a reduction oxidation reaction. Good? Very good. Next, we have this reaction, and we want to solve a problem related to it. Vitamin C, you know what's vitamin C? Ascorbic acid. Everybody knows vitamin C. This is vitamin C. It's available in many beverages. If you go to most of the juices and these things, they add ascorbic acid, vitamin C too. Okay? Okay. This is a drink called Gatorade. Anybody knows Gatorade? Drinks?
Yes.
شركة اسمها Gatorade. You know it. All right. It is a sport beverage. Okay. It has been, we took 25 milliliter sample. So we took Gatorade, and we took 25.0 milliliter sample, all right, which contain vitamin C. So there is vitamin C in it. And we treated this vitamin C, by the way. So I'll take it away. Next, this was treated with 29.25 milliliter of 0.00125 molar to reach the end point. So we have 29.25 milliliter iodine with the concentration of 0.00125 molar iodine. Then how many moles iodine did I use in this reaction?
It's going to be 3.656.
3 point what?
656
times 10 to the power -5.
Yes.
5 moles. What did you do? You simply multiply this, but don't forget to multiply this also by 10 to the power -3 to make it liters instead of milliliter. Okay, you multiply these two together. Who got the same answer? 3.656 times 10 to the power -5 mole. Who got the same answer?
I get it.
Great. How many moles ascorbic acid or vitamin C we need?
The same.
The
Same one.
1 to 1.
That's
1
1
to
to
So this one is 3.656 times 10 to the power -5 milliliter. Can you change this into grams? No, not milliliter, more. I said, I'm sorry. Mole. Okay, can you change this to gram?
multiply by the molar mass.
What's the molar mass of C6? H8O6.
The molar mass is 176.1.
Yes,
Who got the same answer?
I get the same answer.
Yes.
From the periodic table, I hope so. Good. Now, can you change mole into gram? I know that 1 mole vitamin C is equal to 176.1 gram vitamin C. Then how many grams?
6.438
6.438
multiplied by 10 to the power minus 3.
What is this? Gram or what?
Grams.
Gram.
Yes, grams.
Or 6.438 what?
Milligram.
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 Exactly. This is available now. I'll take this away, I hope. This is available in 25 milliliter. I want the whole bottle. 25 milliliter contain 6.438 milligram. Then 350 milliliter bottle. How many grams? How many milligrams?
It will be 90.132.
90?
Yes.
90.132
132.
milligram. Of course, what you did, you multiply this by 350 and divide by 25. It's as simple as that. Who got the same answer?
I get it.
Yes.
Okay, and the answer is 90 milligram, exactly. 90 milligram, what you got is 90.135. Excellent. How easy? All right.
Easy.
Okay, good. Let's finish the chapter now. We finished chapter 4, and inshallah today I'll give you the homework for chapter 4. So before we go, let's close this one and let's start the very good, and then
Doctor, the next chapter is 10 or 5?
10. Next from, Wednesday I'll start chapter 10 inshallah.
Then after that we will back to 5, right?
And then the 5, and then in order 5, 6, 7, 8, 9, 11, and then 13. 12 is not required. Okay, attendance is open. Please go sign and you can leave right away.
يعطيك العافية دكتور.
حياكم الله، مع السلامة.
يعطيك العافية يا دكتور.
دكتور متى نقدر نشوف الأجوبة حقت
بعد 10. أنا حطيت بعد 10 تقدر تدخل وتشوف نتيجتك، وإن شاء الله الأجوبة أيضا وإيش تقدر تشوف بالضبط.
دكتور.
نعم.
متى بيكون إعلان الماتيريال حق المد حق المد ماتيريال والمعدل المد؟
والله سألت عن عظيم.
طيب دكتور، المد بيكون يوم 10 مارس.
نعم.
10 مارس مكتوب في البلاك بورد، هذه وش تاريخ 10 مارس؟
ايش؟
مكتوب عندنا في البلاك بورد 10 مارس يوم ندخل حق الكيمستري حق السكشن حقي، في كذا خانة مكتوب فيها كيمستري مارس 10. بغيت أسأل هل هو موعد الميد مارس 10؟
لا، إلى الآن ما حدد موعد الميد ما تحدد إلى الآن.
والماتيريال بعد؟
ديبيندز. الماتيريال هو إذا الميد تيرم زي ما هو ماشي حتكون، احنا قلنا لكم الماتيريال أول 6 شباتر في الميد تيرم اللي هو شابتر 1 2 3 4 10 and 5. اوكي، اذا الامور مشيت زي ما هي وحيكون حضوري، ولكن الاوضاع الحقيقه تخوف، فما اقدر اجاوبكم هل هو فعلا حيكون حضوري وهل هو حيكون في الشابتر في الوقت هذا. اي دونت، الى الان ما عندنا معلومات يعني.
تمام تمام، يعطيك العافيه دكتور.
حياكم.
دكتور
تفضل
دكتور ممكن طلب؟
تفضل.
إذا ما عليك أمر ممكن تخلي الكوزات multiple choice؟
لا والله صعب، ما يبغى لها فيها صعوبة، وفيها يبغى لها مراقبة، وما عندي مراقبين على أساس يراقبون.
طب دكتور إذا ما عليك أمر، طيب تخليها على الأقل وقت أكثر شوي.
صحيح والله يا دكتور الوقت ضيق جدا، وخاصة إن فايل الأنسر.
هذا ممكن إن شاء الله، إن شاء الله. خلينا نشوف النتيجة المرة هذه على أساس نسويها المرات القادمة.
دكتور في البلاك بورد تطلع لنا الإجابة الصحيحة ولا؟
والله I really don't know. ما أعتقد تطلع لك الإجابة الصحيحة، بس بيقول لك إذا جوابك خطأ أو صح بس.
دكتور سؤال الاباندنس اللي هو الافريج اي ام يو، هو مكتوب الاي ام يو بصغير فوق، ما كنت احسب لازم ينكتب جنبه زي الاسئله حقت الاولد، فتلخبطت فيه ما عرفت. هو عادي انه يكون جنبه فوق.
هو اللي فوق الرقم هو الاي ام يو.
ما كنت ادري صراحه، اني قلت يمكن ناقص سؤال او شيء.
لا
انه دائما يكون مكتوب جنبه على اليمين برقم كبير.
لا هذا هو نفسه. اذا ما اعطيتك ولا شيء، انا قلت لكم في الكلاس تاخذ الرقم اللي موجود فوق اللي هو الاتوميك ماس، الماس نمبر نفسه.
دكتور.
نعم.
كنت بكلمك على اللي انا اقفل عليه الاختبار وما قدرت اكمل.
لما كلمتني ما قبل باقي الا دقيقه او دقيقتين، فما قدرت ارجع لك يعني.
طيب ايش اسوي؟
خلينا نشوف النتيجه خلاص يعني الان. زي ما قلت لك انت لما كلمتني كان باقي اقل من دقيقه، يعني دقيقه كان باقي، فلما رحت للسيستم عشان اقفله لقيته اوريدي قفل على الجميع يعني مو بس عليه.
لاني ما قدرت اسوي اتوقع سيف الا الاجابه واحده، والبقيات حليتها بس انه ما صرت لها سيف.
هو يسوي
يعني ما صار لها سيف. ايوه هي ما صار لها سيف عشان النت علق.
دكتور